this video I'm going to explain you how to make a simple LED chaser circuit. So the idea behind is, I'm going to take a dummy box, so wherein I'm going to stick some LED strips around it. I'm going to control the alternative LED strips with this sequence timer. So let's see what are the components required. So we'll be requiring a breadboard for a connection setup. Once if the connections are correct, then we will mount it to the actual board and we can put into that box. So we need an 4071 IC to sequentially control the LED strip, and a 555 timer which we gonna tune into a stable mode, and 1 microfarad capacitor, and the LED strips according to your requirement. So in my project I'm going to sequentially tune the LED strips, turn on the LED strips around the box. So I'll be requiring around 30 to 40 strips like this. So one is of red color and other one is of blue. And we require 3 resistors for the circuit. So one would be 1K and 47K and 470. If in case you want to adjust the speed of the chaser circuit, we would be requiring an 100K potentiometer that would replace this 47K, and we need a multimeter to check on the resistance, and then 50-volt battery as a power supply, and we require some wires for connection. So once we check the proof of concept in this breadboard, wherein I'm going to try to switch sequentially the colors as red and blue between these two LED strips. So once this is successful, we gonna mount it to the box. So this is the circuit diagram of the chaser circuit. So let's see step by step in detail. So initially I've just mount this 555 timer on this breadboard such that the notch is towards the left. So let's connect this 8 pin towards the positive supply, that is VCC, and let's ground the first pin, and the pin 2 and 6 are interconnected. Now interconnect the pins 4 and 8, and let's place in capacitor such that the negative terminal is connected towards the pin 1 and the positive is connected to the pin 2. Now connect the 1 kilo ohm resistor between pins 7 and 8 and the 47 kilo ohm resistor between the pin 6 and 7. Now place the 4071 IC such that the notch is facing towards the left, and ground the pin 8 and connect the 16th pin towards the positive terminal. Connect the pin 8 and 13 and pin 8 and 15. Now connect the clock input of 4071 IC, that is pin 14, with the output of 555 timer pin 3. So since I'm going to use 15 volts power supply, I'm going to use 1K resistor instead of 470 resistor. So this resistor will be connected between this ground and the negative terminals of LED. Now we have connected the pin 3 to the first LED, and pin 2 to the second LED, and the pin 4 to the third LED. And we can connect as much of 10 LEDs in sequence. So these are the pins which will be used: 3, 2, 4, 7, 10, 1, 5, 6, 9 and 11. In my project I'm just going to switch the circuit between two colors, that is blue and red. So I'll be using just pins 3 and 2. So first just check whether this circuit is working. So I've connected I've just replaced the LEDs with the strips. I've soldered the ends accordingly. So we're just going to use this kind of circuit in sequential strips such that there are plenty of strips coming around that box. So before extending the circuit, let us see how this works when the light is turned off. So if you see this the light switches from blue red and again blue red, and again it comes back from red blue and red blue. The soldering is completed. The circuit which we already saw in breadboard is being mounted on the circuit board. So let us continue to extend this circuit by connecting the LED strips and see how it is working. Let us begin to mount the LED strips around this cylinder. So in my project I have taken a tin material kind of cylinder in order to do my project. If it is a plastic material, it is better to stick as it is, since this would rust by aging. I have painted this tin with white paint. So if you see, I have stuck some LED strips such as from left blue red and blue red. So we will continue this sequence until it covers all the circumference and ends here. And let's drill the holes at this place, and we would be soldering these two pins, and we would connect all the wires in series. And let's connect the circuit which we have soldered earlier, and let's enclose this with lid, and we are going to have a switch on top in order to switch on the circuit. So let's continue to stick the LEDs. So once I have stuck all the LEDs around this box, I'll be drilling some holes at top of the strips in order to wire the connections within the tin, and I'll be connecting the breadboard, the circuit mounted board, which we have completed already. I have completed soldering all these LED strips, and I have stuck them around this circular tin. If you see, it is completely surrounded by this circumference. And what we are going to do next is that going to insulate these terminals such that they doesn't touch each other, and we are going to drill holes between this mouth and this soldered portion, such that we are going to take these wires within the tin, and we are going to connect that breadboard with these wires, and we are going to enclose it completely such that none of the wiring is visible outside. I have completed sticking all the LEDs which we have prepared by soldering the positive and negative terminals. If you see, we have a couple of groups over here. So I have tied 4 per group, and we have drilled some holes at this edges such that the wires will go inside, and the wiring will be clean, and we won't be able to see any wires outside. And I have applied a hot gun glue coat on all the soldered heads, and I have applied and I have heated a iron ruler, and I have ran around this glue such that if we see, the glue is evenly spreaded out. So in later stages, once the complete casing is done, I will be wrapping a thread over this portion such that it evenly aligns over this glue. If we see, we have totally 10 groups, 4 LED strips per group. That amounts to 2 blue and 2 red, and we are going to run these wires inside these holes, and we gonna still make sure that the holes edges are not sharp such that it might cut the wires. So we are going to do some precaution over there. I have completed wiring the positive and the negative terminals. Like we have 44 LED strips, so we have to connect all 44 grounds, and there will be 11 blue 1, 11 blue 2, and 11 blue red 1, and 11 red 2. So we have 5 groups. So we will be grounding one group to the ground of our mounted circuit, and we'll be using 4 pins, that is clock pins, for blue 1 blue 2 and red 1 red 2. We have completed the entire project by enclosing all the wires inside this tin, and I have closed this with a lid. We also have an 100k potentiometer connected to that 47k resistor instead of 47k resistor in order to adjust this switching of LEDs.